Section 1.8, words into symbols. The objectives of this lesson are basically to translate words and word problems into logical math statements, or take these word sentences and make them into equations. The first example, represent each word phrase by an algebraic expression using h for a variable. So part A says a number decreased by 4. Well, how would you decrease a number by 4? You would subtract 4 from that number. So for part A, we're just going to have h minus 4. We take away 4 from that number. For part B, it says 8 more than 5 times a number. So if you wanted to have 8 more than something, you would add 8. So 8 more than 5 times a number. Well, if you want to have 5 times a number, you multiply that number by 5. So this is, again, 8 more than 5 times some given number h. The difference between a number and its square. So any given number, h, and it says the difference between that and its square. So that number minus its square. Remember, for a difference, that the order does matter. So this is the difference between a number, so we put in the order that is shown, a number and its square. Some number, the difference between that and its square. The sum of twice a number and half that number's absolute value. The sum of twice a number and half that number's absolute value. Okay? In part E, we're going to look at is twice the sum of a number and 9. So we have twice the sum of a number and 9. So the sum of a number and 9 is this, but we want twice that, so we have to do this. Twice the sum of a number and 9. Example 2. James left his house and drove for T hours at 50 miles an hour toward the city. If his house and the city are 200 miles apart, how many more miles must he drive? Well, for this kind of a problem, we have to think about what's left over, really. And whenever you want to determine what's left over, you subtract what you've used or what you've done from the amount needed. So we want to go 200 miles. And let's say, hypothetically, we already drove 30 miles. We would say, all right, well, it's 200 minus 30 miles, and that would mean we'd have 170 left. So right away, we know that it's going to look something like this, the expression, 200 minus something. So we start with 200 minus, and let's put a blank here for now. Okay? Again, this was just our example a moment ago. But now we're told that the person is driving at 50 miles an hour for a given amount of hours t. Well, if you were driving 50 miles an hour for 2 hours, you would end up going 100 miles. Now, in this case, what did you do? You multiplied the rate, 50, times the time, 2, to get a distance of 100. Well, that comes from this formula. Remember, D equals RT. So we know that 200 is in miles. Again, the units here are miles. So this is a distance. So this needs to be some distance also. So we take the rate times the time to get the distance that we've already traveled, which is going to go right here. Well, the rate is 50. The time elapsed is t hours. So we take our rate times our time. Well, that's just 50 times t. So this is simply 50t. So the expression in the end that represents how many more miles that he has to drive would be 200 minus 50t. What could you say here? Well, for a problem like this, you could say, think about it for a second. You can't have t be greater than 4, because what happens then? Well, then it would go further or past the location. So once 4 hours go by at 50 miles an hour, then James has already driven the full 200 miles. So t can't be bigger than 4 in this case, because our answer can't be negative for the amount of miles left. We're meaning past the destination. Example 3. Find the measure of the third angle of a triangle in simplest form. If one of the angle measures is k, all right, let's start. And the measure of the second angle is 15 less, it's going to be a minus 15, then half the first angle. Okay? So again, this means 15 less than half of the first angle. And we want to know the measurement of the third angle, which is this unknown variable. Since we know that the sum of 3 angles of any triangle is 180 degrees, we could start by thinking about that. So if I wanted to figure out what the last angle is, I could add them all up and set it equal to 180. Or I could say to myself, if I take 180 and subtract these two angles, this one and this one, I'll be left over with what's left here. So I need to subtract them, but I need to subtract them both. So let's put them together. So I'm subtracting from 180 the sum of the other two angles to figure out what the third remaining angle is right here. So now we want this in simplest form. So we need to first distribute the negative. 180 and 15 gives us 195. And they're both positive. Now, with the k parts, we have a negative k and a negative half k. Well, two negatives, when put together, are going to be more negative. So we have to think about what's happening here. Well, if I have k as a negative minus half k, this is like a full k right here, minus a half a k is really 1.5. It's negative, obviously, but the idea is 1.5. How do you remember this? Well, if this is like $1, this is a 1, and this is 50 cents, you have $1.50. So this is really 1.5. So we could simply write minus 1.5k. Why is it a minus? Because these are both negatives. And when you put two numbers together by subtraction, or in this case addition of two negatives, it becomes more and more negative. We could also have added these two fractions together by looking at them as common denominators. So here, we could have said, well, this is really 2 over 2k negative minus 1 over 2k. And now the denominators are the same, so this becomes, the denominator remains the same, the numerator becomes negative 3, and we have a k. Well, it turns out that this quantity is actually the same thing as this quantity here. Negative 3 halves is negative 1.5. Example 4. In terms of m, what is the sum of 5 consecutive even integers if m is the fourth integer? All right. So in my mind, even consecutive integers are things like 2, 4, 6, 8, 10, 12, 14, etc., etc. They're all even and they're consecutive. We're looking for 5 of them. So we really be like something like this. Okay, looking at the first 5. Well, where's the fourth? The fourth is right here. So we're saying that this is really m in a sense. Well, how do you go from 8 to 10? It's 2 more. So this integer would really be m plus 2. How do you go from 8 to 6? You take away 2. So this integer would be m minus 2. How do you go from 8 to 4? You take away 4. So this would be m minus 4. And to get to 2 would be m minus 6. But what are we trying to do? We're trying to find the sum of these. So let's put a sum symbol between all these. Now, what we're going to notice is that we've got 1, 2, 3, 4, 5 m's, all of which are positive, giving 5m. We've got negative 6, negative 4 is negative 10. This negative 2 and this 2 cancel, so we just have a negative 10 there. So the sum of the 5 consecutive even integers, where m is the fourth integer, is 5m minus 10. Example 5. A train leaves town traveling at 50 kilometers an hour east. 3 hours later, another train leaves town traveling 75 kilometers an hour east on the same track. How long will it take the second train to catch up to the first? So we've got a train that has a head start, but the second one's traveling faster, so it's going to catch up eventually. Now, there's a few ways to solve this. The way I'm going to show you is extremely algebraic. And there are other ways, again, to solve this. But I'm going to show you an algebraic method to do this that is very useful, and you'll see this a lot in physics as well. So we start by saying, remember that D equals RT. Now, these trains are leaving at different times, but eventually the train that's trailing is going to catch up to the train in the end. So really, they're going to end up going the same distances. So we want to start by saying that the distance the first train travels will be the same as the distance the second train travels. And this helps us because here, if you think about it, we have two formulas really. We have the train 1 and we have the train 2. But because these are equal to each other, we could start by setting these equal. So we could say this. Now we know, well, the first train leaves with this rate, the second train leaves with this rate, so we can plug those in. But what we're going to notice is that we have this unknown variable t1 and this unknown variable t2, which is a problem. We can't have two variables in one equation. So we have to use this part here. 3 hours later. 3 hours later. Which means that the time for train 1 is always going to be 3 more than the time for train 2. Because it left 3 hours earlier. So say it takes train 1 10 hours, it's going to take train 2 7 hours. If it takes train 1 15 hours, it's going to take train 2 12 hours because it left 3 hours later. So instead of T1 here, we could say, instead of T1, let's replace T1 with T2 plus 3 hours. The reason that I'm subbing in for T1 is because this problem wants to know how many hours it will take the second train to catch up. Well, the second train is T2. So by thinking about substituting in here for T1, it gets rid of T1, and now we can just solve for a T2. It appears in 2 spots. Let's go ahead and collect terms. Distributing this 50 to both. And then after that, we could say, well, let's just subtract 50t from both sides. T2, really. We're going to get 150 equals 25 T2. Dividing by 25, T2 is 6 hours. So it takes the second train 6 hours to catch up to the first train. So I guess it would take the first train 9 hours to get there because it's 3 hours more. It left 3 hours early. Example 6. You decide to go for a jog from your house and you run south on Park Ave at a rate of 8 miles an hour. So here's your house. You run south at a rate of 8 miles per hour. And then it says an hour later your brother also left home to go for a jog but runs north on Park Ave at 6 miles per hour. How far apart are you after W hours have gone by since you left home? Since you left home. Alright, so remember, distance equals rate times time. That's the first thing we need to remember for these problems. In this problem, think about it. After an hour, you're 8 miles from home. After 2 hours, you're 16 miles from home. After 3 hours, you're 24 miles from home. Because again, you're multiplying. So since your rate is 8, and the time that goes by since you left home is W, that's how far away from your house you are. Now, you have to use logic now. Your brother leaves but goes the other way. So what's happening here is it's kind of like spreading the distance between the two. If 2 trains leave the same location but go in opposite directions, the gap between them is increasing due to both of their speeds. So this is how far you've traveled south, right here. But how far has your brother traveled north? Well, your brother is running, so we'll call this D1. Your brother is running at a rate of 6 miles an hour, but he leaves an hour later. So if you ran for, say, 5 hours, then he ran for 4 hours. If you ran for 20 hours, he ran for 19 hours. So it's always 1 less. So we say W minus 1. Now, remember what I said a minute ago. The distance traveled in this direction is really like your D1. The distance traveled in this direction is like your D2. So if you want to know how far apart you are, you have to add those two together. So we're going to say D1 plus D2 is what we're looking for. Again, we are trying to figure out what D1 plus D2 is. Well, D1 is 8W. D2 is 6 quantity W minus 1. Let's go ahead and simplify this expression. Now, let's take a look at our answer and make sense of the numbers. Well, here's what we've got. 14. Where does the 14 come from? It comes from the fact that you're running at 8 miles an hour one way. He's running at 6 miles an hour the other way. So technically you're kind of like you're running at 14 miles an hour apart from each other. But since he doesn't run the first hour and he's running at 6 miles an hour, we need to take off the 6 miles he would have run in that first hour. So this is going to give us the miles apart we are, minus off the first hour that your brother didn't take account for because he left an hour after you running at 6 miles an hour. So you have to take off 6 miles. And that would be our final expression for this problem. The Mathletes Club at Loyola School has 26 members. The number of boys is 4 less than twice the number of girls. How many of students of each gender does the club have? A little bit of an easier problem. Let's take a look at this. It says 26 members total. The number of boys is 4 less than twice the number of girls. Now, since there's only boys and girls in the club, the sum of boys and girls must be 26 members. But the problem is that there's 2 variables. So what you need to do is take this expression here and go ahead and plug it in for B, because this is the definition of B. B is defined as 2g minus 4. 2g minus 4. So we're going to have 2g minus 4, the number of boys, plus the number of girls, and that's 26. Now there's only one variable, and we could solve for the amount of girls in the club. Continuing, let's combine like terms. 2g and g is 3g minus 4. That's 26, the minus 4 carries down. Adding 4, we get 3g equals 30. So there are 10 girls in the club. Well, it says how many students of each gender, so we have to figure out how many boys there are. If there's 26 total and there's 10 girls, there must be 16 boys. Your homework from this section is out of 1-8 and then some review problems from 1-7.